Good afternoon to everyone. Today I will discuss all about density-based clustering. So what is density-based clustering? Density-based clustering refers to unsupervised machine learning methods that identify distinctive clusters in the data based on the idea that a cluster or a group in a data space is a contiguous region of high point density separated from other clusters by sparse region. So the data points in the separating sparse region are typically considered noise or outliers. Density-based clustering is also known as DBSCAN or density-based spatial clustering of application with noise. It works by defining a cluster as the maximal set of density connected points. There are two parameters that are taken into account, epsilon and minimum points. Epsilon is the maximum radius of the neighborhood and minimum points is the minimum number of points in the epsilon neighborhood to define clusters. There are three classifications of points. They are core, border, and outliers. A core point has at least minimum points within its epsilon neighborhood, including itself. There are points that are at the interior of a cluster. A border point has at least minimum points within its epsilon neighborhood, but can be reached by the cluster. That is, it in the neighborhood of a core point. And finally, the outliers, or noise point, is a point that cannot be reached by a cluster. A point y is set to be reachable from x if there is a path p1 to pn, with p1 equals x and pn equals y, where each p1 plus 1 on the path must be core point with the possible exception of pn. An object y is directly density reachable from object x if x is a core object and y is in x epsilon neighborhood. A is directly density reachable from b. B is directly density reachable from c. A is indirectly density reachable from D. D is not density reachable from A since A is not a core point. Density-based clustering works by picking a random points that does not belong to a cluster or is an outlier and determine if that point is a core point. If not, label it as an outliers. Now, pick another core point at random and determine if it is a core point. If it is a core point, then all of the directly reachable nodes are assigned to the cluster. Then do never jumps to all reachable points and add them to the cluster. Keep finding neighbors until you're unable to. At this point, will be labeled as a border. Now keep repeating step 1 and 2 until all points have been labeled or assigned to a cluster. In this case, the last 2 points are also outliers. Now we have our cluster. At this point, it is important to know the difference between density-based clustering or DBSCAN and K-means. DBSCAN is effective at cutting the noise out of dataset by labeling them as outlier, whereas K-means uses the entire dataset. In this example, we have two sets of clusters resembling half moon, each belonging to different cluster sets. Now, if we add some noise, we can see if DBSCAN or K-means correctly assign the clusters. We see that it correctly grouped the top half moon as a cluster, and it do the same for the bottom half moon. Then, it predict the rest of the points are outliers or noise, which is correct. Now let's look at the same half moon example using K-means. This will also include the noise data points. Now two random centroids start off and the collective points are assigned them. Each centroid is moved accordingly to their new locations. And once again, the collective points are assigned and the cycle repeats until the centroid are at the point where no new point are assigned to either side from their movement once K-means is complete. We can see that it did not correctly predict the half-moon clusters nor the noise. K-means has a huge disadvantage in that it considers the whole datasets and cannot distinguish noise from clusters groupings. It may also identify clusters incorrectly due to it realigns on centroid replacement. Thank you for watching. God bless.